Hello all of you makers, nookers, railroader, terrain diorama builders dealing with another random making encounter. Today we're going to continue our Yogswa series. I think we're video 4 now, and we're actually going to get past all the boring stuff and start making things. So what we're going to do is we're going to, in this first actual example of where we make things, we're going to build on this idea that we have an LED blinking on our board. And like I said in a previous video, one of the main things that I use microcontrollers for in my book nooks and in my dioramas is controlling LED lighting. So let's just start there. It is so easy, super easy, barely an inconvenience to control LEDs and lighting through microcontrollers using Arduino. So for this project, if you're following along out there in YouTube video land, from our starter kit, we're going to have our Arduino Uno. We're going to grab the breadboard, but we don't need the power header. We don't need the power supply on the breadboard for this one. We're going to grab from the LED bag 2 red, 2 yellow, 2 green. You can see we've got kind of a stoplight thing going here, traffic light example going. We're going to need some resistors. I've grabbed a couple of just the regular clear white LEDs. Mostly I just want to show you some differences in brightness when we look at resistor values. So you don't need to grab these, just grab the red, yellow, and green. We're going to need some resistors. Speaking of resistors, I'm going to show you how to calculate for the resistors, but we're going to be using 220 or 330 and maybe even a 1K, 1000. So this is 220 ohm, not ohm like the ohm in Nausicaa, but maybe. 330, 220 ohm, and then 1000 ohm, 1K. The 1K we're going to throw in to see if we can take the brightness of the green down a little bit. More to come on that. We're going to need some jumpers. So these are the little jumper wires. We're going to need the ones that have the little pins on the end. I like to color code as much as possible. You don't really need to, as long as you can keep track of where things are going. But I'm going to grab 2 orange, 2 yellow, 2 green. I tend to try to use red and black for power. You don't need to, but that's why I didn't grab red jumpers for the red LEDs. I tend to use other colors for data and information or other connections, and then leave red and black for power, kind of main power. Okay, what else? Anything else we need? USB cable, that I think will do it. So the first thing we're going to do is we're going to jump over to the interwebs, and we're going to talk about how we calculate resistor values. So let's jump on over to the web. There are a lot of calculators out there to calculate current limiting resistors for LEDs. This is the one I've been using. It's simple, it does what I need it to do, and it just, for this instance, what I really always need is I've got voltage, I've got an LED, and I need a resistor. So I'm not really generally designing complex circuits with LEDs in them, where I need to know how the voltage and how that current is affected sort of downstream. So a lot of these bits of information that this is going to provide would be helpful if you're really trying to understand a much more complex circuit where the LED is embedded in it. We're just powering it, so we can be a little more loosey-goosey. So let's just fill out the form here. We know that our voltage on our pin, our Arduino, is 5 volts. The LED voltage drop is going to vary by the color. Usually you'll look this up on a spec sheet on your LED. They'll come with it, and it'll have all of this information provided, and you can just fill it in. Really, in this case, since we're mixing and matching, I just want to use one value. So I'm going to start with the lowest value for the color that we have. So red is our lowest at 1.8 volts. So I'm going to type that in. The current is about the current rating for the LED, but what's more important is we need to be cautious of the current rating for our pin. So here I'm going to start with 15. Now, obviously, you could get these so out of whack that the LED won't light, but generally, if you're keeping the current low and your resistor values are reasonably high, the worst that will happen is literally the LED simply won't light. You won't burn it out, you won't burn out a pin. But generally speaking, knock on wood, never say never, you should be okay. It just may not provide enough power to the LED to light up. Number of LEDs is 1. Let's click Design Circuit. And you can see that it gives us a resistor value of 220 ohms right up here. Gives us a color code. Be aware that our LEDs in our kit are 4-band LEDs, the color code. You can Google the 4-band resistor values. There are little calculators out there, as well as calculator for everything, that will let you figure out what those color bands are. Or maybe your kit, if it's a grab bag, you might have 3-band resistors. 3 bands are very common. Those are kind of the most generic standard. That's why you see them here. But what's important is we can see down here that the total current drawn by the circuit is 15 milliamps. So that's under our 20, and that is perfect. Great. Now, let's say we wanted to reduce that current down to 10. We want it to be half our value. That gives us a resistor value of 330 ohms. So not a lot more, but just a little bit more. And so we know that if we picked a resistor between 220 and 330, we should be okay. Now, let's do one last little tweak here. Remember, we had this voltage drop. If I go to the blue, and let's say we plugged in the high end, 3.5 volts. Let's see what that will do to our resistor value. Okay, so basically it's cut it in half. So we know that if we increase that voltage drop value, we're actually reducing our resistor value, which is not the direction we want to be headed. We want to always be erring on the side of the higher resistor value. So if you're jumping in and you're fiddling around and tweaking values, and you're plugging values in and you're noticing that you're driving your resistor values lower, you kind of want to start with always that highest resistor, calculated resistor value. So I hope that all makes sense. Generally speaking here, the worst that can happen is you can blow out an LED. LEDs are reasonably inexpensive. We just want to make sure that we're protecting the pin on the board. So we're going to keep those high 220 to 330 resistor values. We're also going to look at a 1,000 ohm resistor in our circuit and see that we can really crank those values up and still get the LEDs to light. So let's head back over to the board. Now that we know our resistor values, and again, you could use anywhere from 220 to 330. I'm going to start with the 220. That's going to kind of give us the best brightness for the power consumption that we want. But we may look at really quickly the difference between 330, especially I've got these two side-by-side comparisons just to see really what that means. And then we'll later on sneak in this 1K somewhere. So we're going to keep these handy, but we need to put all of this together. So a couple of things that you need to be aware of when you're wiring up LEDs. There is a polarity. That means that these need to go in a very specific way or they don't work. And if they don't work, it's very possible that you have wired them in backwards. So if we look at the LED, there is a long lead, there's a short lead. There's also a flat side of the LED. So if you look really closely at the base of the LED, it's round, 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 and then it's flat, and that flat aligns with the short lead. On an LED, the long lead is the positive, and the short lead is the negative, or the flat is the negative. So when we put our LEDs into our breadboard, what we're going to want to do is we're going to put the negative side into the negative rail. So it's going to all be sharing a common negative, common ground. And then we're going to jump over to a row in the main part of the breadboard and plug the positive in. So I'm going to kind of do something where I put it in here, kind of bridge it over, wiggle that in, and we should be good to go there. Okay, so we're going to skip a row. So what I did was there are 5 rows per kind of chunk here. So I'm going to do 1, skip, 1, skip, 1, and just do 2 of those. And I'm going to get all of my LEDs plugged in. So when you look at the side here along this negative row, all of these edges of the LED is where the flats should be. And then also if you were to pop it out, the long lead would be to the positive, the short lead to the negative. With all of your LEDs plugged in, the next thing that we want to do is put our resistors in. So when you're putting a resistor in, you may need to bridge different distances. So this is really kind of a way to put LEDs in nice and tidy if you're really close to, close to the points you want to connect, and you want it to be nice and clean and compact. You make a little teepee out of it. So what I do is I just bend on close to the resistor on the end, bend it over to make a little triangle there. And then you, just to make it easier to put it in, I will take a little snip here, and kind of make the legs the same length. Resistors are very, very inexpensive. You'll go through a lot of them. You can buy bags and bags of them, especially if you find that you keep using the same values over and over in your projects. So now that this is kind of nice and there's an even little edge there, I can put this in, and what I want to do is I want to follow the same row. So I'm going to pop this one out. I want to follow the same row, come across. I want to stick one end in the common same row and then jump over the middle, because as we talked about, these rows, there's a gap in the middle. So I want to jump over that because this is where we're going to connect our power in. So we don't want, if we do this, if we were to have it on the same side like that, and we plugged power in, basically the resistor would do nothing. What would happen is the connection behind it would form a short, the line power would go straight through, bypassing the resistor. There is that whole concept of path of least resistance. Kind of this is where that comes from, or could be applied to. Might apply to water too, but path of least resistance means that electricity, in this application for that phrase, electricity is going to follow the quickest way where there is no resistance. There's nothing, it doesn't need to do any work, and so it's going to just whip right by, and that is also sometimes called a short. So we're going to jump over and make sure we've got that bridge between it. And we're going to just go through and put our 6 resistors in, lined up with our LEDs. When all is said and done, you should have something that looks kind of like this without these. Okay. Very easy. This is super easy stuff. Nothing complicated, nothing to be stressed out about. The next thing that we want to do is we want to connect our Uno to the LEDs, but if you've been following along, you should already have blink running on your Uno. With it powered up, this little LED should be blinking. So very quickly, what we want to do is just take a black wire. We need to create a circuit. So I'm going to take it and plug it into this ground, to the ground. And then I'm going to plug it into the ground on the Arduino. So that is the one that's got a little white that says ground there. Jumps out at you so you can see it. Now what I could do is I can take a jumper. This LED pin is, or this LED is on pin 13. So if I plug a jumper into pin 13 and I plug it into one of our LEDs, you can see that it is working. It is, when the pin goes high or turns on, it now will blink our external LED as well. So we know that we've got this wired correctly. we can go through and we could, test our different circuits to make sure that everything is working. So basically what's happening is the Arduino is providing 5 volts of power to pin 13. When we drive the pin high, we'll talk about that in a minute, but when the pin goes high, turns the power on, we have a ground, they share a common ground, which is shared with the board, and we get an LED light running through our resistor to control current. So, great, that works. Awesome, perfect. Let's wire up the whole kit and caboodle. There's a bunch of ways that you can wire things as far as logically to, pins to your thing that you're wiring. It's really up to you. Really, you just at the end of the day are going to need to remember what pin goes to what thing. Just to keep it simple here, what I'm going to do is I'm going to go just sort of up from low to high, from bottom to top, just so that the wires are all nice and tidy. I'm going to skip the first 2 pins, the transmit and receive, and start with pin 2, and that is going to be a green jumper into my green. Pin 3, whoa, easy there, it's not your turn yet. Pin 3 will go into, with a yellow jumper, into, remember we're skipping, into the next row up, the next skipped row to the yellow LED, and then orange will be playing the part of red, so pin 4 will go up into this next row. That should look good. And then we're just going to continue on and repeat. Now, one thing to note, if you were wanting to use pulse width modulation, and we're going to be doing that in the next video, we're going to fiddle with these. We want to lean these videos down a little bit. You will need to use pins that have the tilde on them that associates them with pulse width modulation. So we should end up on pin 7, and that looks pretty good. Just make sure you're skipping a row because that's what we're doing here. Green, yellow, orange, 2 through 7. And remember, we always start on 0. So it's 0 is receive, 1 is transmit, and so those we're skipping to keep those open. Okay, I think we're ready to start coding. So let's jump over to the computer and write a little bit of code and get some things going. When you're first getting started, it's actually when you aren't just getting started, a lot of times your beginning point in a project will be some existing code out there in the world, some existing sketch that you are going to, again, use as a basis for your project. And then our goal is really to learn how to bend projects, bend sketches, bend code to do the things we want to do, the specific things we want to do. So we're gonna follow that sort of philosophy, and we're gonna open up the Blink program, and it's going to be the basis for our little stoplight exercise that we're going to do here. So here we have Blink, and right now it's not going to do anything on the board because really it is blinking the built-in LED built-in, which is pin 13 in this case for the Uno, and we don't have anything connected to pin 13. But we actually have some beginning code that we'll be able to use for our project, so we don't have to kind of reinvent the wheel and start completely from scratch. So what we're going to do is we're going to actually just select all of this comment. We don't need it. We're going to change this substantially enough that it is going to become more than beyond Blink. So we can go ahead and delete all of that. But what we do want to do is in this top area, we want to, one of the first things that you may often do is make some variables. So a variable is a symbolic name for something that holds a value, and that value can never change or it can change constantly, so all of the time. So variables by their name are symbols, a name for something that can hold a value. This will make sense as we go on. There are lots of different types of variables. We're going to just keep it really, really high level and simple. So we're going to type int, which stands for an integer. And then we're going to come up with the name of a variable. So we're going to call this, let's do red 01. So this is going to be our red LED number 1, and we're going to say equals, and we're going to put a value on that. Now this is where those different relationships of the pin to the LED come into play. So if we wanted our topmost LED, the top red one, to be our first LED, our first red LED, that is on pin 7. And then we're going to put in a semicolon. Never for the semicolon is the one thing that is always tends to be forgotten, and it will be the one that will throw an error all the time. We're going to type in yellow 1, and we're going to walk them down. That's going to be pin 6. We're just putting the number of the pin in. I'm going to say int. We're going to say green 01 equals 5 semicolon. Now, instead of having to like type all of that again, be efficient with your time. Copy. I'm going to paste it. So I did Command or Control C, Command Control V, and just duplicate that so I don't have to type all of those. So this is red is going to be pin 5, 4, 3, and 2. And we need to change this because now this is no longer red 1, this is red 2. Copy gold leader, and we're going to make this one yellow 2 and green 2. We can't have duplicate variable names. It'll throw up an error. Not physically throw up, it will digitally throw up an error. So what we've done here is we have defined all of our pins, and we don't have to go back, and if we were to use these pins and we have a really complex sketch and we're wanting to swap a pin, if we just use the pin value down in our code, if we make a change, suddenly now we have to go and find all of the instances of it in our code. That's a real pain in the butt. What we want to do is we want to just be able to change it up here and use the variable name for all of our other stuff. So that just keeps it super duper simple. So we've defined the pins, a little variable. One nice thing you can do is if you go up and you go to Tools and you go Auto Format or Command Control T, that will allow you to kind of tidy up the code. You see how it kind of formatted that a little bit and made it all nice and neat. So it's always nice to do a little quick Command or Control T. I think it's Control, maybe whatever the PC version of that is. I should know this. I'm on PCs all of the time. Okie dokie. It's just muscle memory. All right, so what we've done is defined our pins. Now, if we go down in the blink, what we want to do is it says this needs to initialize the pin as an output. So we're not going to necessarily do that. I'm going to delete that one because we're going to tweak it a little bit. But we need to turn all of these pins to outputs. And so what I'm going to do is I'm going to change this to red 1, 0, 1, red 0, 1, and make it an output. So now pin 7 has been turned to an output. Hoping this makes sense because red 1 means 7. And I'm just going to paste, whoa, undo. Easy there, sharpshooter. 3, 4, 5, 6. We need 6 iterations of this. So now we have to just change. This is going to be red. This is going to be yellow 1. Green. There's a lot of, I should have probably just done the first 3 again and saved myself a few keystrokes. So this is red 2. This will be yellow 2 and green 2. And that is red 2. I'm going to do a quick little format here. I don't need these curly braces. Those are not what we need. Those got copied and pasted by mistake. So we're just going to tidy things up here. So that is going to be what is in our setup. And as we talked about in the last video, everything in this void setup, when the board powers on or you push the reset button, this happens one time. So it's turning all of the pins, the digital pins, they can be inputs, they can be outputs. We want to power out on the pin, so we want to put them all to output. Red, yellow, green, red, yellow, green, 2, and that should do it. So now that's good. Okie doke. Let's do a quick little test. We're going to just try to blink one of the LEDs. So what we want to do is just basically take one here. I'm going to say I want to blink red 01, and I want to blink, do that, turn it on and off. We'll talk about how it's doing that here in a second. And I'm going to hit, make sure my board is selected on the right selection, on the right port. Hit upload. And now, with a little bit of luck, my first red LED is blinking. Now, why is it blinking? The command that we're going to use is, or the code that we're going to use is digital write. So if we want to, by using digital write, we're basically saying, go to that pin and we're going to toggle it. We're going to turn it to on, basically, high, on. We're going to send voltage to the pin. So digital write, define the pin, set it to high, it turns the LED on. Delay is in milliseconds, so 1,000ths of a second, so 1,000 equals 1 second. And so delay stops or pauses the program. As we talked about in the last video again, that this is a procedural programming language, so it just runs down the line. And when it hits a delay, it's going to actually pause for the duration of the delay. So basically a second here, then it's going to do another digital write command. And in this case, we're going to say low, which turns the voltage off. It drops the voltage. It goes low. The pin goes low. No voltage. Turns the LED off. We're going to delay for another second, and then we're going to go back up, and we're going to turn the pin back on. We're going to do it all over again. So that is the basis of all of the things that we want to do. Now, here's where we just very quickly, with a little copying and pasting, turn this all into a traffic light. So it's just a matter of turning things on and off. So I'm going to get rid of all these single line comments because we really are not needing them and they're no longer relevant to us. So the first thing that we want to do is, let's say we want in our stoplight, the first thing we need to do is turn the first red LED to stop. And then we want to, I'm just going to copy and I'm going to paste. We want green 2. So the second green LED, green 2 on our other stoplight, to be low. It's off. Oh, actually, no. Yes, it's off. Green, red's on. No, it's high. Man, I am just... How do stoplights work? Sorry there. Okay. Wow. Man. So let's test that. So we're going to also... So red 2. Okay, now what we're going to do is we're going to copy this. And we're going to paste it. And we're going to have it go low too. So we're going to do a little testing here. Okay, so in the first thing, red... On red 1 is stop, but you can go on green. Yeah, I know how stoplights work, theoretically, allegedly. And so we're going to pause for a second, and then we're going to turn them off. So let's load that up into the program. Okay, so now, yes, now we're cooking here we're cooking with gas. So we're able to turn both of these off. So let's bump this pause up a little, delay up to like 3 seconds. So 3,000 milliseconds or 3 seconds. So they're going to stay on for 3 seconds. Then they're going to turn off. But what we need to do is we need to turn the yellow lights, the proceed with caution lights, on for some period of time. So I just copied and pasted those high commands, paste those in. And we need to change this to yellow 1 and 2. So yellow 1 and yellow 2. To go high, they're going to stay on for a second. So short light, quick yellow. Then, so that's hopefully making sense. So when we look through so far, we turn red 1 and green 2 on. We're going to keep those on for 3 seconds. Then we're going to turn both of those off, and we're going to turn the yellow lights on. And then what we need to do is, the next thing logically that we'll do is we're going to, we can copy these. After this next delay, we're going to paste those in. And this is just like flipping the light switch on these. We're going to go low, turn them off. And what we need to do is, when those go off, what we want to do is basically do the reverse of this. So I'm going to copy, and I'm going to paste. And instead of red 1, it's going to be red 2 and green 1. So the opposite. So you can go one direction. We're going to turn them off, proceed with caution, turn off the proceed with caution, and turn on the opposite of that. We have it sitting and delaying for 3 seconds. And you can, when you're building something that you want to mimic or replicate out in the real world, these delays, obviously, you would have it, you know, no light is, well, some lights maybe around my house might be 3 seconds with a 1 second proceed with caution, but you'll push those up to numbers that make sense. And we can actually, down the road, we're going to talk about how to add some randomness to it that makes it feel less repetitive. So we'll talk about random values in a future video that make it feel more organic. But right now we're just going to do the same thing. These lights stay on for 3 seconds. And then what we want to do is we want to basically, after the 3 seconds, we need to go to this sort of second block, but in reverse a little bit. We're going to swap these first two, but we do want to turn the yellow on and off. So honestly, we got to figure out where our loop comes in, but I'm going to basically grab everything from this digital write yellow low. I'm going to grab that all the way up, copy that. So you can see where copy paste is becomes your really good friend. I'm going to do a little bit of tidying up. The one thing I need to do is I need to reverse these. So I turned red 2 on and green 1 on, but I need to turn red 2 off. Whoops, not that. Red 2 off and green 1 off. Okay, now I think this will do it. And then we'll do a quick little run through again and see. So I can check my code to make sure I don't have any errors by clicking the check. It'll compile it. It's done compiling, no issues. I'm going to hit upload. So red, stop, go. Proceed with caution. Go, stop. Proceed with caution. Stop, go. Proceed with caution. There we go. Nice. So let's talk a little bit about commenting. If I wanted to put a comment in just to keep it sane, I could put 2 forward slashes and I could say, you know, stop, go. And then down here, after this next delay, maybe I go, you know, what I just said, proceed with caution. And then after this one, maybe it's just so that I know that the order, go, stop. And then down here, we've got one more, proceed with caution. So you can see, like, throwing in comments can help provide a little, you know, little tips and tidbits of where you are making changes, big, you know, kind of big chunky changes in your code. I'm gonna save that. I'm not going to save it. I'm going to save it in a minute. I don't want to pull up the save screen. So you can see now that this is working. Now, one thing that I want to point out on the LEDs here, on this first green, as it cycles through, you'll see that it's pretty intense. And so what I've done with this second green is, rather than having a 220 ohm resistor, this has a 1K resistor, 1000 ohm resistor. And you can see that it actually is significantly dimmer. Now, we don't usually, there are other ways to dim LEDs besides reducing the current to them. And if you put too much of a resistor in, you may just basically make it not necessarily work, but it's hard. Like, realistically, if you think about it, 220, this is five times, give or take, more resistance than the 220, and it's still working fine. So what that also tells you is, when you're selecting resistors for your LEDs, specifically LEDs, other components, when we're doing things, resistor values can become and will become more important that we have specific values, because it will mean more. But LEDs are kind of a very imperfect component. And so the difference between 220 and 1000, I'm taking a little bit of that edge off of this green. And it also means that I can pick, if I don't have a 220, but I got a 300 or 330 or 500, it'll probably work. We don't want to go lower than, but above and beyond, it'll be fine. And so as long as you've got the minimum that you've calculated so that you don't damage the LED, you should be good to go. And again, with a 1K resistor in here, basically we're drawing even less current on the board. Now, if we think about our power consumption, we've calculated each of these resistors so that the value that it's drawing on the board is no more than 20 milliamps per pin. And then if we do the math, we only at any point in time have 2 LEDs lit. So if we do the calculations on the power draw on the board, we say 200 milliamps maximum on the board. These are really only probably currently drawing about, let's just assume we've got 15 to 20. Let's err on the high side so that we know that we're kind of overdoing it. Let's say that each LED was drawing 20 amps, 2 LEDs lit at any given time. That's 40, well below the 200 milliamp on the board. So that is really kind of our first doing a little bit more fancy stuff with LEDs, making them a little bit more sequential. We didn't really look at these over here. We can ignore those. But where it's more relevant really is this application where this had our 220 ohm resistor in it, and this had a 1K. If I were to build this out for reals, I would definitely go with the higher resistor value, because right now this is feeling a little hot over here. And I might even bump up on the red, the LEDs. Each LED will have a certain sort of sweet spot for what it wants from a resistor, and it can vary from LED to LED. So I hope that was really helpful. One of the next things that we're going to do is we're going to talk about what happens if we want to control more than the 20 milliamps that are available to us on the pins, because really out in the real world, a traffic signal will have, for example, if we stick with this example, a traffic signal will have more than just two lights, right? There will be 4, right? You've got each direction at an intersection, each direction has 2. So we're starting to really add up, and we may be starting to tax the amount of power that we can draw from the board. And we also may want to find ways to be a little bit more efficient, especially when we have something like 2 LEDs on the same line, right? So if we're looking at this stoplight example, if you're going one direction of traffic, basically there are 2 lights that will have similar stop go caution. So we can get some efficiencies out of a different way of controlling LEDs, and we'll be using transistors or MOSFETs to do that, where we'll have basically a little sort of electronic switch that we'll be able to use the microcontroller to toggle on and off. And this is a great other trick tip to be able to control things like motors that have much higher power requirements. So it's a good one to understand how to use MOSFETs or transistors to control power using an Arduino. So again, hopefully these things are helpful for you. I hope you can find or think of applications for these in your project. So if you're making a book nook or a diorama and you're wanting to turn lights on and off, we're going to actually create some circuits where it will sense our external environment, or it might sense motion and turn things on. So as people approach or walk by or wave their hands over things, but this is really going to get us started, and we're just going to build from here. So again, hit those like and subscribe buttons, click the notification bell, all that good stuff. Affiliate links down in the description if you want to get the kit to follow along, and we'll see you again on another random making encounter. Until then, it's always good hanging out with you.